You ever hear a term in machine learning that sounds just impossibly complicated? Stochastic gradient descent. It's definitely one of those phrases that can make your eyes just glaze right over. But what if I told you that behind that beast of a name is something, well, something much, much simpler?
Yeah, you heard me. The core idea behind one of the most powerful algorithms in AI today isn't some scary lion. It's a kitten, a blindfolded kitten to be exact, on a very, very simple quest. So today, let's follow that kitten on its journey.
So what is this big quest? It's actually pretty straightforward. Find the bottom of a hill. But, this isn't just any old hill. In the world of machine learning, this is the hill of error.
So this is basically what being wrong looks like to a computer. For an AI model, an error isn't just some number. It's a whole landscape. Every peak you see is a point where its predictions are way, way off, and every valley is a point where it's getting closer to the right answer. This entire landscape is just a map of the model's mistakes. Now, this map of mistakes has a formal name. It's called the cost function. And you can think of it like a magical GPS for our little kitten. It takes all the super complex stuff an AI is doing and just crunches it down to a single number that says, you are this wrong. The higher the number, the higher up on that hill our kitten is.
And that's the whole game, right? The entire goal of training one of these models is to get that cost number as low as you possibly can. For our blindfolded kitten, that means getting to the absolute lowest point in the entire landscape, the very bottom of the deepest valley, where the error is as close to zero as it can get.
Okay, so how does our kitten even find the bottom if it's blindfolded? It uses a really simple strategy called gradient descent. At any given spot, the kitten just feels around for the steepest downward slope and takes a step in that direction. And then it does it again and again. Step after step, it's always heading downhill. And that, in a nutshell, is gradient descent.
But what about that first word and that scary name, stochastic? This is where things get really interesting. It's basically the difference between, say, studying an entire textbook for a test versus just quickly flipping through some random flashcards.
So the word stochastic, it just means random. Seriously, that's it. It means we're injecting a little bit of randomness and uncertainty into the kitten's journey down the hill. So instead of a perfectly planned, straight path, its journey is going to be a little messy.
And this breaks down how that works. You've got the old school approach, batch gradient descent. That's like reading the entire textbook before taking a single step. It's super thorough, but man is it slow. Then there's our method, stochastic gradient descent. It's way faster. It's like picking one single random flashcard, learning from just that, and taking a step immediately. The most common method today, though, is mini batch, which is a nice happy medium. It just grabs a small handful of flashcards at a time.
And these flashcard methods are really the key here. They make the whole process so much faster. But because our kitten is only looking at one tiny piece of info at a time, its path down the hill isn't some smooth slide. It's more of a wobbly, zigzagging stumble. And believe it or not, that wobble is exactly what makes it so powerful.
Now, before we get to why that wobble is so great, we have to talk about the size of the kitten's steps. In machine learning, this is called the learning rate. See, if the kitten takes steps that are too big, it might literally jump right over the bottom of the valley and end up on the other side. But if its steps are too tiny, it could take forever to get there. Finding that perfect step size is a super important balancing act.
All right, so here comes the big reveal. Why is this wobbly, random, uncertain path actually better than a smooth, direct one? Why is being a little bit messy a good thing?
Well, the problem is something called a local minima. Imagine our error landscape isn't just one big perfect valley, but it has lots of little dips and shallow potholes all over the place. A simple downhill algorithm could easily just roll into one of these dips and get stuck thinking, hey, I'm at the bottom, when the real, much deeper valley, the global minimum, is just over the next ridge.
And this is where the magic happens. A smooth, predictable path would totally get trapped in that first shallow valley, thinking the job is done. But our stochastic kitten, with its wobbly, noisy path from learning on random flashcards, it doesn't get stuck. That noise gives it just enough momentum to kind of jump out of those shallow traps and keep exploring, eventually finding its way to a much, much deeper valley, which means a far better solution.
So, you see, the randomness isn't a flaw, it's the entire point. That wobble is what helps the algorithm avoid settling for just good enough answers and instead pushes it to find truly great ones. It is absolutely a feature, not a bug. So, okay, we followed this blindfolded kitten on its wobbly journey down a hill. It's a cute metaphor, sure, but why does any of this actually matter in the real world? Well, because this little kitten is basically the engine behind almost all of modern artificial intelligence.
Think about it. This simple process, our blindfolded kitten taking small, random, downhill steps, is the fundamental way we train the most complex AI we use every single day. The massive neural networks inside language models like ChatGPT, the recommendation engines on Netflix or Amazon, the systems that recognize your face in photos, deep down, at their core, they are all powered by this little kitten's journey.
And that brings us right back to the beginning. The next time you hear that super intimidating phrase, you'll know the secret. You can just kind of smile to yourself because you know it's not some terrifying lion. It's just our determined little kitten finding its way down the hill.
And that's really the beautiful secret behind all of this. It's a simple process of learning with tiny steps, guided by random flashcards, one little piece of information at a time. It's a simple idea that leads to incredible, bite-sized brilliance.
So I'll just leave you with this final thought. The next time a machine learning model gives you the perfect song recommendation or a startlingly human-like answer, just take a second and ask yourself, will you remember that underneath all that complexity, there was just a blindfolded kitten wobbling and stumbling its way to the right answer?